right, so this is a presentation about 1, 2, 3, 4. Like, where's my clicker? How many of you use LinkedIn? Come on. How many of you use LinkedIn? How many of you use LinkedIn today? Okay. If I would ask this question maybe some time ago in the past, this answer would be different because one of the things that the people at LinkedIn were trying to do is increase the engagement for their system, because there are a lot of people hang out in LinkedIn, and they wanted them to hang out there more. And one of the things that they decided to, okay, so how about we will give people some features that allow them to go and get back to LinkedIn more often. And one of those features was who viewed my profile. How many of you use this feature at least once? Like, if you never Googled yourself, that's probably would be the next best thing for you. Go try it. It's called who viewed my profile. You would know within the minutes of this someone look at my profile. And by the way, shameless plug, connect to me on LinkedIn, and I will be able to see who viewed my profile after this presentation. And to build this, LinkedIn is known to be a very event-driven system. Apache Kafka came from LinkedIn. There's a lot of events that happen on LinkedIn, so they already have this data. They already know who clicks around in the LinkedIn. But now they need to figure out how to do this. And this is a very analytical question, because when we establish difference between analytics and transactional systems, we do have one is when we care about one particular record, and with analytics we care about the story. So how we can get the story out of this data? So they try the existing tools and they come up with something new. And the something new that they come up with was Apache Pinot. And today I'm going to talk about multiple things. And but the Apache Pinot would be a central component of this. Apache Pinot, it is a database that's anyone heard about the Pinot before this presentation? All right, few people. Okay. Oh, okay. All right. Like, this probably most important slide if you need to leave immediately, but you still want to have some demos or some information. That's the probably best slide. You can take a photo, and after that you can go. You never miss anything, because, like I said, this is the most important slide. I would like to talk a little bit about how I like to differentiate the analytics. And with analytics, we seen different patterns that you can be placed on across this plane. One of these most common and most known is the internal and batch analytics. The reporting is a good example of this. You have a very important person who works in the company. They need to give a report every month to understand how company is doing. It's a batch because we need to have all information about the sales for the last month in order to execute this. Some like old school dashboard that you usually print and go like hang somewhere in the office. For a little bit on the real-time side of things, you have a special type of analytics that are real-time, but they are internal. And by internal, I mean the analytics that are important for you to run your business, but it's not something that you sell as a part of your application or something, your service or whatever. It's something that is important for you, so you need to know how, I don't know, like what's the load overage on these cloud machines, or how many nodes of Kubernetes you used, and how much money you pay. So this is the real-time but internal analytics. And now there's a very emerging type of the analytical workloads called user-facing analytics. They both real-time and they external, meaning that something that you show to your customers or like give this to your users. This is something that is analytical in nature because it allows you to give them ability to see the data in the different dimensions, but also it is real time, meaning that they need to have relevant data that's relevant for them. I usually show a thing called Whoop. I don't know if you're using a thing called Whoop, WHOOP. Anyone? Whoop is a pretty cool thing. It's like a tiny device that I wear, and it just collects the heart rate information. But it also gives me information about how I performed during workouts, how well I recovered during my sleep, and so far and so on. So this is a real-time data because the data comes from my body, and I care about how I slept the moment that I woke up. So there's certain expectations how this data will be available, and also it is my personal data that is kind of like sliced only for my use case. So that's user-facing analytics. And this, you still can have your batched and external. It's typical use case where you have your banking statement that's sent to you every month, and you will getting this like reporting feature about your banking transactions. And there's a few representatives of these categories. And we're gonna spend a little bit of time like here. Anyone using like some of the technologies that I mentioned here as well? Like apart from the Pinot, maybe some one of you using the ClickHouse maybe. Anyone? ClickHouse, Rockset, Star Rocks, Druid, Apache Druid. So this is the category of the software that serves user-facing analytics or like real-time analytics, how they like to talk about. This is something that's kind of like if you would be exploring feature-wise, they might be similar, and as always, devil is in details. And this is how this like real-time analytic would look like in the real life. So next time when you come in to your LinkedIn, now you know this dashboard runs by a huge cluster of Apache Pinot that was purposely designed to serve and solve these type of problems at scale. My name is Viktor Gamov. I work as a principal developer advocate at a company called Confluent, original creators of Apache Kafka. The reason why I'm doing this talk because I used to work in a company that were founded by original creators of Apache Pinot, and I still kind of like to even though I moved to a different place to work, I still, that's kind of like a professional thing. I still do, if I'm responsible for delivering talk, I will deliver. Java Champion, I wrote the book about Apache Kafka. You can Google it, it's Kafka in action. And yeah, it's just like to test if you're still with me and you're not sleeping or whatnot. Now, so Apache Pinot, it is a distributed database. It is on OLAP database. It's an analytical database that's designed to serve data with very low latency in situations when you have a very high concurrency and you have certain requirements on data freshness. So that's why when we're talking about real time in this particular case, we're not talking real time in computer type perception. We're talking about user perception. It's less than seconds. Like everything that less than 100 milliseconds is great. Everything is lower, awesome, but not necessarily. So your human eyes or like users who will be consuming this type of results of these queries, they will wait a few milliseconds. Three categories, that's probably second important slide in order to understand what this the database, like real-time analytical database mean, is that you have requirements on the latency. Latency should be low, obviously, and let's put some numbers here. So as low as the 10 milliseconds, individual queries, but those queries can be a huge number. There will be high concurrent environment, hundreds of thousands of queries. And situation with LinkedIn, like this dashboard will be hit and populated with some data, and hundreds of thousands of people will try to access this data. Not necessarily they will be hitting the same Pinot cluster or whatnot, because Pinot has certain requirements or certain features in order to solve with the multi-tenancy. You can have a one large cluster, slice and dice it, or have a multiple different clusters that would be solving the particular use case or particular dashboard. And we're going to talk about how to how this cluster is organized next. Just a quick refresher. Again, When we're talking about OLTP type of databases, we care about individual record. We care about that the data would be not corrupted. Data, each individual record will include information that was, I don't know, captured from the web form or whatnot. When we have an OLAP, we're interested in story. We're interested in certain aggregations over certain period of times or different dimensions. We care about individual columns maybe more than individual records or individual rows, because we care about what was the average rating for this movie, what's the max, what's the mean. This type of queries we're going to be solving with Apache Pinot. Apache Pinot uses the traditional tabular model because it is natural for people to think about data in the form of table. So Pinot uses same tabular format that people like to use. The way how these things are created and designed and implemented is slightly different. There's no engine, or there's no like a SQL queries that allow you to create those tables. You need to create those tables slightly in, I can say, in cumbersome format, because you're doing this in JSON. You define fields, types, and also when you do ingestion of this data, you also need to configure some sort of like ingestion jobs, or it will be retrieving data from streaming sources, how we're going to be looking next. Queries express a SQL. It's a standard SQL. SQL 92 use the same framework that many Java-based systems use for parsing SQL. It's called Apache Pulsar. Well-known, widely adopted frameworks for doing all things SQL. And Pinot used the standard SQL, so there's no like custom SQLs for this. As I mentioned, the tabular structure, this is how we define what we're going to be querying. But underlying the system would be slightly different. We do have columns, we do have rows, we have columns in the table, but since it's an analytical system, it can have like millions of rows that you want potentially scale, and everything would be dependent on the storage. And there's no particular limit kind of like for the table, so you can have all these things relatively big, so, like considerably big. We're defining this with a JSON file. And this is my favorite. This is the place where I usually kind of like bring up the joke about what's the most the hardest problems in computer science. And some people would say there's a cache and validation, and the second one is naming things. So naming things is hard. Like, think about this. Like the offline and real-time tables. Like, if you're thinking about offline tables, you're thinking that, oh, there's probably some disconnect between, so tables might not be available. Is it like a cold storage? Like, what does it mean? What are we talking about? But essentially, this is how we call the tables that were ingested from any type of batch sources. We call it offline tables. They totally online. You still can query this as soon as this ingestion process will be done. Then this data will be available for query. Now, real time. This is something that you can kind of figure out. Okay, real time is probably something that you can get from real-time sources like Kafka or Pulsar, and you will be right. So, like, should it be called like not offline, maybe kind of like not real-time, or something else? And yes, some of the tables can be real-time, and some tables can be offline. Yeah, nomenclature is interesting. And since it's an analytical database, we expect that some of the columns would be dimensions, where you will be slicing, dicing your data. Metric, actually something that you will be care, or in order to execute some of the like range queries about the times, it can be date or time. Now, it's a second place where I usually make a joke about the naming of things, because the things that Pinot use, like underlying things, and many of you already kind of like figure out what I'm talking about, because segments is essentially your partitions in some systems, or essentially your shards in some systems as well. So it's the actual unit of storage, the files that will include data that will be stored inside the segments. So those things very similar across the board. If it's a real-time table or if it's a offline table, only difference that some of the segments in the real-time tables will do a little bit more than segments in offline tables. And real-time tables, those segments will include like piece of machinery that allows to extract the data for streaming sources as it comes. It's going to be consumer from perspective of Pulsar or Kafka or Kinesis. So it will understand the topology of the source. For example, Pinot tracks in the monitor like offsets and monitor the mapping between partition in the system like Pinot and Kafka, and how this will land into segments inside the Pinot. And we do support whatever you have your favorite format to ingest the data. Most likely Pinot knows how to read this and ingest into the tables. There's some integrations, but with the Spark, Flink. Let's do t-shirt. I was working hard on this t-shirt. Yeah, it will be relevant for 2 more weeks, and after that we're done. So there's integration with Spark, Flink, and Hadoop, so you can like actually ingest right after your jobs. I do have a different way how I like integrate the things, because some of the things that I will show you today will not require coding, but like if you want to do Flink, ingesting things directly to Pinot, you need to write code. There's no kind of like SQL declarative approach to do this. Tables contains of multiple segments. The segments can be replicated. Now, this is the important thing. So each segment has a columnar structure. Columnar structure meaning that each the dimension, metric, or the date and time will be placed in one segment, all the values. So let me show you an example. Say I do have this clickstream event that includes like IP address, some user, time, user agent, and all these kind of things. Now, when this information will be collected, there will be multiple rows in JSON file. And after that, I need to parse each individual row and turn it into the structure that Pinot will understand. So in this particular case, segment for this table would look like this. Each segment, each table will include segments that will include all the values of this particular type. Let's talk about IP address. So we have a batch file that includes thousands of records from the clickstream event, and each will have certain number of IP addresses. All these IP addresses will land into IP segment. Something like this. So we have a record, but we're turning this record, and now we care about the columnar structure. So every IP address would be stored in one segment. So when we will be executing the query planner will hit particular server that will serve particular segment, and it would be easier for this in order to perform aggregation, for example. Now, let's talk about like very simple things, and this is where you actually can turn on this microphone, because I will be do typey things. So it works. Okay, nice. Okay, so like I mentioned earlier, with the with my GitHub link, let me do this slightly bigger. I apologize for that, and we're gonna do this one. So how's that? So we're going to go with the folder number 1. Exhibit number 1. That will include 2 components. One component is a Pinot cluster, and another component is the file that we need to ingest. So let's take a look on this one. While I will start my automated demo, if you want to replicate this at home, you will be able to do this without any issues, because if you have a Docker installed in your computer, you will be able to to repeat everything. I do have a data. Let me quickly show you how this data would look like, and this is how data would look like. Apart from the speaking at the events, I really like to watch movies because I spend a lot of time in hotels and airports. That's where I watch like majority of things. Also building majority of the demos, and all my demos will be somehow related to the movie. So information about individual movie, 920 movies that I found that would be in a format that can be queryable enough. Each individual row will represent this JSON. So that's the data we will be dealing with. Now, we need to tell Pinot how this stuff would look like. And for this, we're going to use this the schema JSON that will have definition between, like, there's a movie ID, type, title, type, release year, type, and so far and so on. And now when we have a schema for this table, where is it? Yeah. When we have a schema, now we can define a table. So think about the schema is our the class, and we do have the table that would be our implementation of this class, or like interface on the implementation interface, or like class on the object, depends from where we're coming from in terms of like object-oriented programming. Now, we can specify different things. We can specify how this table would be spread across cluster. Would it belong to a particular tenant if we design in multi-tenant system, and so far and so on. For this use case, it would be pretty simple and pretty easy to 150 would be more than enough. Okay, so Pinot comes with a I can say fancy UI, more or less. It's okay UI, considering it's a kind of like engineering design. I think it's a good UI that allows you quickly see what is going on in the cluster. We do have a one controller, brain of this operation. We do have a broker. In this case, it's a one broker, but broker is something that will be handling queries and sending queries to servers that will be hosting your segments. So if I go to the server, I will see that this particular server will host this table, movies offline, and also I can learn about the segments, what kind of file contains this information. So if I click here, I know location of this file. Since I'm running this in Docker, it is somewhere inside the container, so that's why the path is TMP, Pinot, data, movie, JSON, and so far so on. Controller is the brain of operation, broker responsible for queries, a server responsible for storing the data in the segments on the file system. That's kind of like, that suggests. Any questions, suggestions, something that is not clear with this? Because I will be building up on top of the same idea. Every time when I'm talking about, and they see that there's quiet room, it is two things. If it's everything is clear or nothing is clear. And since it's quiet room, for me it's difficult to understand which one's which. Everything's clear? Okay, sweet. Now, we're going next into another point. When I said offline, I was kind of like half joking about this thing. So the way how the Pinot was designed from the very beginning and why these tables have this name is actually inherited from overall architecture. When we need to run these ingestion jobs for batch type of workloads, files from the file systems or like object storage or whatnot, segments will be created outside of Pinot cluster. Pinot will be notified only when the segments will be created, and those segments will be would be kind of like available for adoption. So that's why kind of they will be created offline, outside of cluster. So it kind of makes sense when you start learning things, but from other point of view, engineering design leaks into nomenclature, leaking abstractions. You know, we know all this type of stuff. Now, so this job we need to specify what kind of type, and you don't have to remember all these kind of things. It's in documentation, and usually there's only a few things that you will be running. So there's a segment generator job that will be responsible for creating segments and pushing these segments into the cluster. In this case, it will be using this local Pinot file system to read files. S3 supported. You can move the files from any blob storage and the HDFS, you name it. We need to next specify that each individual record in this file. So we're reading this, and now we need to create our column. So in this particular case, it's called JSON record reader. So we expect that each individual line will include JSON line. It's not JSON object, but JSON line. And next thing is that we actually specify that, okay, so this is how we want this data to be structured, and because we're going to be expecting this to query, and we can fine-tune how this data would be populated. Again, creating schema, we're creating table based on the schema, and we're creating job to populate this data. Now, we're going into streaming initiation with Kafka and Pulsar. Usual use case where I want to show things is where we do have some data that came from our batch source, and now I want to enrich it with some real-time data. These days, everyone is critic. Everyone, go in their phones and start writing reviews saying the Joker 2 is a crappy movie, blah, blah, blah. They ruined my hero and stuff like that. It's an amazing movie. Don't read reviews. Go watch it. It's a great movie. It's a great cinematography. Lawrence Sher is a genius. But I can use this use case because it's a good example of real-time use case. We have a movies that is some data that we can enrich with real-time rated movies. So I'll have no one is actually writing these reviews for me. But I do have application that hits the Pulsar and generates these ratings. And now I will be able to have two tables. I have an offline table with my movies, and I do have a real-time table with my ratings. And I will be able to run the join query. That's probably the most frequently asked question. Okay, Victor, you're talking about database. Can it join? So let's get this out of the way. Yes, it can, and I will show you how this would look like. So let me kill this previous example, and we're gonna go with the next one. This is exactly how this would look like. We have a Pinot. We will load our file the same way as we did, and now we also will have application that will pushing some data into Pulsar, and after that, I'll show you how Pinot can read this and make available immediately. Oh, we'll go in number 2, and we'll go into 04, Pinot and Pulsar. Okay. While it starts, I will quickly show how this would look like. And now, with the with the real-time table, the things slightly will change. Again, I will bring back our known suspects. So we do have a controller that is the brain of operation, some of the data stored inside Zookeeper. Brokers will be responsible for receiving these queries, for querying the data, and the servers will be responsible for handling load. Now, our server will create so-called consuming segment. Apart from being the segment that will be storing the data in tabular format, also, by the way, I didn't mention this, but it's important to say, in order to have very good performance, and Pinot is like knocks socks off competitors in terms of performance, because the very rich the collection of indexes, and those indexes actually stored inside the segment next to the column of the data. So in this case, the creation of this indexes, they will be collocated together with actual data. So the data search and data retrieval will be fast. Now, back to this. So consuming segment will include this, the Pinot, the Pulsar consumer, and the data will land in this consumer segment immediately, and it will be available for consumption also immediately. After a certain time, there's some configurations that we can configure on the Pinot. Pinot will actually flush some of the information from the memory into file system, so it will be preserved, and we're gonna be consuming this data in this consuming segment. So now let's get back to this demo. Now I'm going here, and now I see two tables. One table is the movies that we saw already. Oh, I didn't show you how I can query this. Okay, let me quickly show you. So that's my movies. I can do something like, for example, I can do the standard queries. I do have only two, the best Christmas movies. At least the first one is the best Christmas movie. Anyone disagrees that Lethal Weapon is a Christmas movie? Die Hard, Christmas movie? 100% Die Hard is okay, but the Lethal Weapon is 100% Christmas movie. Things happened in the Christmas. In the very beginning, you have a Jingle Bells, and the Riggs makes his arrest in the Christmas tree fair. It's a Christmas movie. Now, now we have a movie ratings. And the movie ratings would look something like this. And they are not working for some reasons. We're going to explain this why. Let's see if my table is configured correctly. Usually demos are like this. Hopefully the Pulsar producer, let me try to restart a producer so I can see the data will be, yeah, so we're producing some data. We can cancel it. Let's see if I can run. Yes, movie ratings are coming in here. And if I'll just do, I don't know if you can see this count. And I run this query. We're loading the number of documents were scanned, 3,000. And let me show you how it's done. In table configuration, for real-time table, the ergonomics is slightly better than in offline table. Sorry. The same thing with schema. Schema is the same kind of definition. You need to define your metrics. You need to define your dimensions and the date and type. Now, but for actual table configuration, apart from the things I just showed you with the previous one, with tenant, brokers, and table configs, replication factor, you now have this streams config. This is where you put in configuration how you would connect to your streaming service. Pinot supports out-of-the-box Kafka, it supports Pulsar, and it supports Kinesis. So you will be able to ingest this data without anything. You don't need to have a stream processor. You don't have a Flink. You don't have, if you know how your data would look like, and like you understand the schema, maybe it's not changing often, so you don't need to worry about this kind of schema evolution because the things are slightly quirky in this department. But once you have it, you can connect to the topic and start consuming this data. I'm specifying that's my Pulsar topic that I'm consuming, and I'm defining the stream type. That's it. So after that, when the Pulsar consuming segment inside this segment will be reading the data, every 1,000 rows it will be flushing into the disk. So, like after a certain time, if I run this query, I do have, what's the count? The 17,000. So that's, data is still going in my, I don't need limit here. Can I do this? Something like, can I do this? Yeah, for example, movie underscore ratings. And I can run, your analytical query on top of the data. So I already have the information about the average, mean, max. So all these functions are supported out of the box. So the things what you expect will work here. Any questions so far? So we had some data that it comes from traditional batch store. We have some data that come from the streaming store. What we want to do? I want to test if you are paying attention. Someone said, Victor, but you promised to show us joins. Of course, I promised you to show you joins. Join. And the things would look something like this. Again, we have a movie ID is defined. We have a ratings movie ID also defined. So I will be able to run this query. And obviously, I forgot to click this use multi-state query engine. So the Pinot is for for better force, includes two engines for performing your queries. Simple queries that don't require joins, don't require any kind of like a smart navigation with the data. They don't require a multi-stage engine. They would use what we call the single-stage query engine, which is general scatter-gather. So we have a broker, gets the query, reads the metadata from controller, sends the data to particular segments, and after that send this data back to the broker, and broker sends it back to the client. With this multi-stage query engine, so what we do, it's more kind of like brokers and servers like figure out if the data, since the servers, they will have segments on the same kind of same key would be collocated somewhere together. So you will include this join to run on particular servers. After that, you will bring it back to like one of the instances of the brokers that will be responsible for shuffling things around. It will join the data and send it back. So now, my join, if I run this query, would look something like this. So now my movie information included only information about initial rating. Now we do have information about latest rating that was calculated. The rating generator are not smart enough in order to generate totally random. At some point, it actually peaks towards the 10 out of 10. Very I like movies. Like I don't hate them in general, so I like everyone to succeed. But some of the movies, they don't have to exist, but it's like beyond the point. Like the 10 rating is good rating. Now, so we do have a join. Now, this is the place where we're gonna answer one important question. What the heck about Flink in this particular case? And usually the answer is like, for this, is something that is related to the point where people asking, does Pinot support joins? Answer is yes. And this another question people asking, does it support materialized views? And answer, unfortunately, no. But we can do something with this, and this is where the Flink comes into play. So Flink it's not a database. Flink is the framework for doing stream processing things. And Flink can process things that come in the form of unbounded stream, meaning that it's a real stream and you don't see when the data will end. Or it's a bounded stream that will be like some case of unbounded stream. The Flink can have multiple sources, can be files, can be Kafka, can be Pulsar, database, key value store, and it has multiple things, including databases, key value stores, and as well as Kafka. Now, so what we're gonna do, so I'm trying to speed up a little bit in terms of how this will work. I'll show you what we're gonna do. Now we're going into a world where we don't have a batch. We're in a world where everything is a stream. In this particular case, my movies, same thing that I have with my files, it's another stream, but it's bounded. So meaning that it's only limited to 920 records. We do have ratings that you already saw. Those ratings also unbound. So we're gonna do, on the Flink side of things, we're gonna do join. And after that, we will connect this constantly updated materialized view to Pinot. So from the Pinot perspective, it will be constantly reading data from rated movies topic, but in principle, this would represent our materialized view. That's at least I will try to achieve. Now, we going back into my demo. We can destroy, like, it will take just a moment of the time to restart this. But essentially, how are we going to do this? In Flink, we're going to create a few tables. In this particular case, we're going to, let me close this one. We do have a couple things. We do have a create table statement that will include information about movies, but in this case, in Flink, we're going to be using this, the Pulsar connector to read the data from movies. We're going to create, I'm going to create, and you will be hopefully witnessing this awesomeness in just a second. I'll create movie ratings, same structure that we just saw, and we're also operating with the SQL that relatively similar. Only difference that this is the way how we can configure these connectors inside Flink. And now we do also have a rated movies sync that will have a connection to Pulsar when we finish with our join. And at the end, we're gonna do something like this. So insert into the sync and the result of our select. So this is materialized view that we will be maintaining outside of Pinot. We will be maintaining this in Flink. And if I will just run this, it's run SQL client. We'll just do quickly few more seconds. Yeah, that's the whole purpose. Hopefully, okay, we get this. We're gonna do. Otherwise, it's gonna be homework, but everyone hates homework. So we do have a sync. So I will create this. I'll show you that this actually works, and I can do the same query that I use with Pinot because they use standard SQL. And Flink also uses. Let me. So this is stuff that Flink kind of like a process this, but this is not materialized anywhere. Flink doesn't have a storage. It's just in memory. When I close it, it's gone. The result is gone. So we need to materialize it somewhere. In this particular case, so what I want to do is this how we do this materialization type of logic. When I run this data will run in the background, and the Flink will be constantly meeting the streams, and will be joining those streams. And if I did everything correctly, I switch back to my Pinot console. I have a rated movies table now, which has rated movies. That includes information about updated ratings. Where is it? Yeah, this is the rating, that updated rating information. If I run this query, not the 10, let's do count so we can see it actually works. No, I do have some good query. Say, yeah, no, yes, I'll do select star count. And we don't need this, and we should run queries. So this is the number of rated movies. Obviously, if I will do like select distinct, this should relatively small number. There's some error, but I will figure out this error after. Now, why? It's all about latency. It's all about use case. This is the great illustration why you want to have ability to move your queries too far. There's no microphone. Yes. This is a picture that illustrates very well like where you want to execute a query. If your latency requirements are too high, you cannot perform joins, or have amount of data that will not be able to you will not be able to benefit from this running these joins. Maybe you need to just like offload this into stream processing that will be maintaining your materialized view and providing you with the one big table that analytical databases are love, because you can assign the indexes and all this kind of stuff. In joins, you still will be benefiting from indexes, but not the way how you will be do like table scans and stuff and so on. This is the count from the book from my friend and colleague Hubert Delly, Streaming Databases, very good book. I highly recommend to pick up together with the Kafka in Action book. It's also a pretty good book. Pick up this the source code. Find me in Twitter, Blue Sky, where have you Instagram. Ask me questions. Add me into LinkedIn. My name is Viktor Gamov, and as always, have a nice day.